marshmallow and just like, that's it, you know, and just puts it in the table, and it's just one noodle high, and spaghetti noodle, so it's like a foot or whatever, and that's it. And then usually the other problem that kindergartners have is they usually eat the marshmallow. And the CEOs, on the other hand, do pretty much the same thing. They're just like, okay, we'll just make a simple thing here, and I'm not trying to prove anything. And the people who score the worst are, the engineers and other people, because they spend the whole fucking time just bitching at each other, and trying to make something super complicated. And at the end, usually they get nothing, absolutely nothing. So it has to do with having effective leadership with random people sitting around, stuff like that. It's at one point, one of our producers on Dragon Age Legends did that with our with people on our team, and so you can see the animations are now playing. They're not playing at the same speed or anything else, but like, there we go. We're controlling stuff that we weren't controlling before, and we're controlling it in blueprints. Now let me see what I was doing before. So it's basically like, the people who have the most leadership skills recognize that just getting the damn thing done is more important than getting it done perfectly. And also, leadership skills of a kindergartner are sometimes better than the leadership skills of, random person, because the kindergartner, doesn't really give a shit. They're more like, just don't eat the marshmallow, So, in this case, I think I am not the CEO. I am not the kindergartner. I am the person who you don't want building that marshmallow tower. I am the engineer that overcomplicated things. And Adam was like, whatever, fuck you. I don't understand any of this bullshit. And I guess you might be saying, I'm thinking Adam's a kindergartner. And you might not be wrong. Because I've never actually met him in real life, except like once or twice. Maybe he is in kindergarten. I don't know. The reason why it's so difficult to get stuff finished. Alright, well, I'm gonna double check real quick on how I'm playing the animation durations. So yeah, I've got this like duration speed stuff going on. And I really didn't have a whole heck of a lot here. It was just start at 1, it looks like, percent to next. The min duration is the default duration times 1, and the max duration is default duration times 0.5. The default. So we're getting the total duration default at 60 frames per second is what I'm doing, I guess. So wrapper, flip broke, get total duration. We want to get the animation duration, get the total duration of the flipbook. Are we even using the frame num here? No, we're just calling get on it. I'm just trying to think of the best way for me to get this, because I basically need all the different speeds that I have there for walk, run, and everything. And they need to be in one easy to edit place, and I think that's on the movement controller. So what I need is I need all the substates to be able to access the movement controller by their class type, the expected type, and get the speeds for their animations. So we need a couple things here. We need be able to grab variables from animation controller, not animation controller, the movement controller. And we need to be able to grab flipbook data, or be able to grab information on animation by name. Be able to grab information on current animation by name. So this would be like the total time, total duration, etc. Total duration, frame count. Let's see, I think it's going to be just like get yeah. Is this playing? Right. Yeah, so we don't need that. So the duration here needs to be this, and we need to like, we're going to basically be calling this every frame, and the animation controller is going to be dealing with it. So we need to like get the animation by ID. Yeah, I think so. We need to get the animation information by ID, and then we can call play on it, because blah. So let's see. We don't want to just get the animation ID, we want to get the flipbook out of this thing. So it's going to be like Dashkin animation controller, and we're going to want to like get flipbook, or get animation data by ID. Animation exists. Get animation ID by name. Get animation by type and set. But what does this F animation wrapper have? So let's go to the declaration for that, which should be, I believe, over here. Alright, where the fuck is it? There it is. We have the flipbook. Alright, so we want the get animation wrapper by name. Alright, it's going to be right here. We need to get animation data. Should actually get animation data by ID. Should be this one. And this will be get animation data. And it'll take a const f string. Alright, so let's do it. Alright, so int32 animation ID equals get animation ID by name. Name animation ID is less than 0. Return null pointer. That. Otherwise, return get animation by ID. Animation ID. And this is safe, so it's going to be animation by ID safe and null wrapper if we have it otherwise. And I guess we need to make an animation exists with const f string reference. Alright, so if animation ID equals is less than 0, return false, otherwise return true. And this the animation ID exists for the ID one. Alright, let's see if that works. And then we need to be able to grab those variables off of our animation controller. So we need a way to expose either we need to grab our variables in our movement states. An appropriate pointer on this. Cannot have exposed pointer to this type. Because it's a struct? Alright, so I guess we don't need the safe version of this thing. Yeah, I see. Alright, so by ID. It sucks that we have to change all this stuff in C++ land because we want to use it in blueprints, but that's just what we gotta do. Just had those two swapped around. Excellent. Alright. So now let's figure out how to get those speeds in our movement controller nicely. Like they should be public variables. Discovering asset data. Alright, finished asset. Let's go. So we've got the movement controller. We've got these run, air, blah, 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 blah. So basically this movement controller has these variables. These variables need to be this variable type is a float. Variable is public. Okay, so I can just make all these public variables? Alright, so if we're inside of our walk state, what we want to do is we want to get the parent object. So what does our movement state have? We've got the entity actor. We want to grab the movement component, and it needs to be of a specific type. So I guess I want a variable here which is our parent, and it's going to be a type of it's going to be a bitey movement controller. So when we initialize, we're going to set our, we're going to get our movement, and then we're going to cast to, well, let's see if I can just, it's not compatible with movement controller reference. Movements is Dashkin movement. reference, I guess. Cast to bitey. So we just do it like this. And then we can grab stuff off of it. I mean, that's not incredibly... That's not the worst. Like, that's okay, I think. So we can then call, like, parent get, and then we want, like, the sprint. Get the sprint speed? Yeah, so we can do that sort of stuff. So we actually want to do this state transition, this animation playing stuff. Like, we kind of want to make it a function, and we want our current speed and all that sort of stuff. Get velocity magnitude, absolute value. Get animation data, and we want the walk idle. Trying to reproduce what I've got here for the movement component. Alright, movement object. Let's see. So what we do is we calculate a percent to next. So we got the magnitude here. We need to get the well, should I just reproduce this stuff, or should I actually start messing around with other things? I'd like to just reproduce it first, just to make sure I've got my kind of stuff in order for this. Like, I've got all the actual... So we need... This is the walk. So the walk should have trot speed. So we need the trot speed, and we need the walk speed. So it's going to be, we need to subtract float minus float. It's going to be the trot speed minus walk speed. And then we get the trot speed minus the velocity. Trot speed minus the velocity. So it's trot speed minus the absolute value of the velocity. I'm actually going to copy this node out. And then we do a divide. So it's going to be this number divided by this number. And then we're going to do another subtract. Alright, so we need the get total duration. We actually have to break the flipbook out. Get total duration. So it's going to be we're going to add float. We're going to basically add the default duration, and then we're going to add, this is a percentage right here to the next level, and it's going to be, we're adding max minus min multiplied by it. So we want we need an add float, actually a subtract. So it's going to be max minus min, so it's going to be like we're going to take this value and, geez, yeah, this is multiply float by float, two of these things. I guess I could do this shorter just by multiplying this by well, this is easier to conceptualize. This is 1 and this is 0.5, and then these two basically multiply, you subtract. And then we do a multiply. And then we do an add. I mean, it's that simple, right? Like this is obviously just the simplest operation you can imagine. Right here. You know, like this is just very, very clear exactly what this does. It does the thing. You know, just all this bullshit right here is super easy to follow. Like if you're looking at this and you're like, all right, well, what actually happens here for all these things? I mean, it's real easy to follow, right? You take the trot speed and the walk speed, you subtract those, and then you divide the absolute value of the trot speed subtracted by the velocity magnitude. Take 1 and subtract what you got from all that garbage, and then you just take 1 times 0.5 times the total duration. You just multiply that by this thing, and then you just add that to the total duration, and that's your duration. That's just pretty simple. Anybody, any third grader can understand that. That's not true at all. So what seems to me is what I want is... Oh, I'm going to need some more math utils here. I need a math util for percent between. So we need percent between, which would basically take all of this stuff. And the velocity magnitude should be the absolute value. So I can get rid of that. Let's see. I need some easier animation data functions. We need like get animation duration. To make this easier. Alright, so why don't we just go ahead and do that. Let's just test this thing real quick. So I'm actually going to get rid of this stuff. So what should happen is, at least with the walk, we should get it rolling around here. I should be able to change inside of the movement controller very quickly like we can just change the trot speed from, well, it's interesting. It's actually not easy to change a whole bunch of stuff here once you've got it set up. Like, I could just get rid of all these lines here. It looks like what we actually want for this walk state Yeah, we're actually making it slower. Okay, well the logic's wrong. Anyway, we need to change all that regardless. Let's go to our movement controller. Make sure we save and compile all that stuff. Close that down, and let's add to our mathematical utility methods. Math utils. Right, and our movement object stuff. One thing at a time, though. So what we need is a static float percent between values. So it's going to be float min, float max. And what this is going to do is it'll give you basically a percentage between the two values. So if you're really close to 1, it'll give you like, you know, clamp it from 0 and 1 and all that stuff. So it'll be float percent between values. I guess we need 3. We need the value, the min and the max. And we'll have another one for integers. Percent between ints and percent between floats. So it'll be int value, min, and then max. Alright, so it's basically going to be float percent equals, it's going to be, what's the value? It is, and basically this one is just going to return percent between floats, and it's just going to pass in value and max. So we'll convert to floats and then do percent there. So percent is going to be, the value minus the minimum divided by the maximum minus the minimum. Alright, so if percent is greater than 1.0f, return 1.0f. If percent is less than 0, return 0, otherwise return percent. And see how much easier that is to like just type out in C++ than it was to actually like drag nodes around and bullshit like that. Yeah. So a percent between floats, and we also want to do inverse percent. And percent inverse between ints. Alright, so we need the velocity needs to be the absolute value in our movement object. Alright, so now we need to be able to grab information on the current animation, like total duration and frame count. So we need like this get animation data, but we need a little bit more. We need like get animation. Maybe the F animation wrapper should have methods on it, like get duration. I mean, we have get default duration and all that sort of stuff, like just right here. So maybe we need those. But I think we should also have some methods on the actual animation data, so let's do that right after we fix this up. Yeah, I think this is probably better is to do this sort of stuff, and we don't want to use this animation wrapper stuff anymore. Like, it's just not helpful for us, I think. So I think we only need the, and we probably also only need the duration here. Like, the loop doesn't matter, and neither does the reverse. So it's just the default duration stuff. Alright, so get default loop, get default duration. Alright, and then the F animation wrapper stuff. The F animation wrapper, where was that anyway? Of course, can't find it. Alright, let's get default duration. Should I just implement it here? I mean, we could. If flipbook does not equal no pointer. Do we have to include paper flipbook? We do. Okay, so that's already there. So let's do this. This is inside of generated code. Okay, so. Well, then we should not put this in here. Alright, well, let's go ahead and generate the code then. Alright, so generation, templates, Dashkin came, CP, this was inside of entity data. So let's check that out. Alright, so we're going to have get default duration, and inside of here, call duration. Let's just call it get duration. Alright, let's generate that code. And I had to save something, so gotta redo that. Alright, get duration is there and all that. Alright, cool. So let's go ahead and build this and see what it does. And the question is, can U structs have U functions on them to make them easier, or are U functions not supported on U struct? I hope they're supported. That'd be kind of silly if they weren't. U structs cannot contain U functions. That's so stupid. Fine. I guess I'll just call it get duration. Stupid U structs. Alright, cool. So let's compile that. And we should have fixed all those little things that we needed. The inverse, grabbing information, velocity magnitude, and animation duration. So it should be now much easier to access all this stuff from Blueprint. So just the simple things. Just simple things. So compile this up, and then we should basically be able to simplify. Capital I is missing here on our math utils. We spelled it right here, but then we got it wrong over here. So we should have a much easier time multiplying some values together in order to get our duration. And basically what we're doing was we're going from like trot to like walk to trot, and we want the animation to advance at a different speed based on how quickly you're moving. So if you're like closer to walk, it would go slowly, and if it was closer to trot, it would go faster. easily multiply that out without having to do that ridiculous spaghetti, like, what was it, like 7 operations in order to actually compute that value? Percent inverse between ints. Alright, yeah. Int32s are not set up properly there. And what is this? Initializing cannot convert from F animation. I guess this is supposed to be a get animation data. Alright, so okay, I need a get animation data pointer return here, and we need to return, like, return wrapper, otherwise return old pointer. And this thing needs to call get animation data draw. Pointer equals null pointer, then we return s null wrapper, otherwise we return star pointer. To get the animation data raw. Get animation data there. Alright, cool. So that should speed things up a little bit. We'll probably have to replace that get animation data by D with get animation data by name and all that, and speed it up. So we're not just iterating over everything every single time we want to get an animation, which is what we're doing right now, which is not a great plan. Animation. We can fix that. Alright, so we can actually just go ahead and do this if we want. We can have it by F string to that, or we could have some sort of key code combination sort of thing. Let me just look it up real quick. Question is, should I just use strings for looking everything up here? Or should I cache the IDs for things and then try to do that? I mean, the whole point of using the blueprint stuff is that we're trying to make it simple and easy to code, not that we're trying to like make things actually, you know, absolutely ridiculous. So I think we're just going to do a const f string of animation lookup stars here. So it'd be like their animation name lookup. Alright, so we'll add in our name lookup. We'll get animation by data by name. It's just if animation lookup dot contains let's just look up the tmap definition real quick. No, I want the real docs, not the crappy docs. Let's see, operator, blahs. We've got contains and all that. Yeah, there's no real good way to do it. Alright, so that should fix up a few things, make it a little bit more efficient.